So now we're going to talk about what's called permutations. And I'm going to start with my race example because it's probably easier for me to explain that. So let's say you're, running a marathon and you're going to give prizes to the first, second, third people, third places, right? Like the people that come in first, second, third. They get a ribbon or something. Okay. So let's say 100 people are in the race. Think about what we learned on the counting, fundamental counting principle. So how many people could, okay, you have somebody that's going to come in first, you have somebody that's going to come in second, and somebody that's going to come in third. Like how many different ways could that happen? Well, how many choices do you have for the first place? If there are 100 people, then you have 100 choices, right? Anybody could come in first. But and then how many are going to come in second place? Well, the person who came in first can't come in second. So now you only have 99 choices. And then how many people could come in third place? 88, right? Because you already had two people cross the finish line. Okay, so you could multiply those together and get how many permutations there are for 100 runners. And we say I'm sorry, got a little mistake here, taken 3 at a time. Okay. So we're just interested in how many ways we can do the first, second, third place, okay? And you'd multiply those together. I'm not going to do it, but you can do that. Okay, so now in the book they give this example, but we have a little league team, okay? And there's a roster, and we have to come up with a batting roster. How many different ways are there? Well, it depends on how many players we have on the team, 13 players, but only 9 can be in at a time, right? Like somebody has to sit on the bench. That's my position. Anyway, so we have 13 players to choose from, but we need 9 of them to be on the team. So you can think about 9 places here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many choices do you have for the first person? 13. Okay, so your leadoff batter, you have 13 choices. How many choices do you have for the second batter? 12, and then 11, right? And then 10. You're counting down like this. This should look familiar. Then 8, 7, 6, 5. Okay, then you're multiplying those to get how many ways you can fill out that batting roster. Okay, this is called a permutation. All right, so there's a lot. You get a calculator and you multiply those out. All right, permutations are based on 2 things. First of all, you can't repeat the choice. So just like, in the race, you couldn't have once the first runner crosses the line, he can't go back and be the second runner, right? So just like on my little league here, we've got 13 choices, but once I place the number 1, the leadoff batter, now I only have 12 choices for the next spot, okay? And the other thing for a permutation is order matters. So if you've played baseball before, or watched baseball, the batting order matters, right? You want your really strong get on base hitter to be the leadoff batter because he's going to get the most times at bat. Anyway, baseball. It makes a difference which order they come in. Now, over here, you've got first, second, third. Makes a difference, right? If you come in first or if you come in third, you get a different ribbon if you come in first. Okay, so that's what permutations are. Keep this in mind. Now remember in chapter 8, there's a lot of formulas, notation, things that are new. You're going to want to make a good note page for that part of the final. Okay, so the notation for a permutation is we say P, and then we have a subscript N, P for permutation, and a subscript R. Okay, so we say it's the number of things, N things, taken R at a time. Okay, and the big thing to remember is order matters. Okay? All right, so there's a way to find that. The P of n things taken r at a time, the number of permutations, is n factorial, right? Like this kind of looks like a factorial thing, right? Over n minus r factorial. So that's the formula right there for a permutation. Okay? All right. So let's see if we have an example here. You and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 different officers, a CEO, an operating manager, and a treasurer. In how many ways can those offices be filled? Now you could just use the fundamental counting principle, but we're going to use our fancy new notation. Okay, so how many people do we have? How many things do we have? You and 19 friends, that's 20, right? So we're trying to find the permutation of 20 things, 20 people. And how many are we taking? We're taking 3 at a time. So, and that'll tell us how many different ways we get our officers. Now, does order matter? Yes, because it makes a difference which one's the CEO, which one's the operating manager, and which one's the treasurer. Okay, so it is a permutation. Once you're the CEO, you can't be the other two, right? You can't, hold 2 positions, I guess. Okay, so permutation, if I scroll back up, look at the formula right here. So it's n factorial, n is this one. So it's going to equal 20 factorial over 20 minus 3 factorial. Now, remember what we learned about factorials and how to simplify them. So you've got 20 factorial over 17 factorial. Okay, so we can write that out as 20 times 19 times 18 times 17 factorial. We're just going to go to 17 because then I can cancel all of that. So 17 factorial, those cancel. Now I just have to go 20 times 19 times 18. So I'm going to put this in my calculator. It's going to take me a minute. So 20 times 19 times 18. Oh, my calculator's not on. Okay, 20 times 19 times 18, and I am getting 6,840. So a lot of times our answers are big numbers because there may be a lot of different ways we could get these combinations. Okay, it's kind of surprising, but that's why the lottery is so hard to win because there's so many different combinations, right? I'm sorry, permutations. Okay, well, it depends on how the lottery's set up, I guess, if it's a permutation. We are going to talk about combinations in a little bit. Okay, so that's what it is, 6,840 permutations for the ways to get those officers.